Chapter 1 is about statistics. Statistics is in our lives a lot these days, and most papers put it out, most news articles put information out on it. Um, and so statistics is very important to understand. What we're going to do today is talk about some basic ideas behind statistics. So this is actually what we consider part 1 of statistics. Which is all the definitions and so forth that you need to have to do statistics. So these are kind of the statistical basics. You would think I could spell statistics, but I can't. There we go. So the statistical basics, these are kind of like our definitions of kind of what you have. Most of these definitions are things that you probably know already. You probably think you know, I should say it that way, in terms of what statistics actually means. And really, in statistics, a lot of our definitions, we don't actually, the wording we use is a little different. So like as an example, a variable is any characteristic that is measured. Now, most of you think of variables from an algebra class as like an x value, but a variable can actually be anything that is measured. And because it can change from each person to each person. And it doesn't have to be a numerical number that's measured. When we think of measured, we think of numbers that we calculate, or measure, I should say. But a variable is just anything that is what we consider measured, if you want to put that in quotations. So it really isn't where we measure it. You could actually measure somebody's opinion on a topic. You can measure a height. You can measure different things with different ideas. And these are all measured from individuals or objects. So they don't have to be people. They can be anything that is measured from. An individual is not necessarily a word that we use to mean people only. It could be anything. Once I have this variable that I'm going to measure, I need to know what group I'm measuring it from. And that is what is called the population. Now, population, you think of a population in your life as being a person or a collection of people, but that's not what a population is in statistics. In statistics, a population is a set of measurements from all individuals or objects. So it doesn't have to be, it's not a set of people, it's a set of numbers or measurements of some kind. They don't always have to be numbers, but it's a set of measurements. You want to be able to answer who you're going to measure and what you're going to measure from them. And that population should answer both those questions. In reality, it's very difficult to get a population because it's sometimes huge. I mean, if you wanted to find out what the age of all the current U.S. senators is, well, that's easy. There's only 100 of them. You could easily measure 100 people's ages. If you want to know what was the diameter breast height of every tree in the Coconino National Forest, that would be a little harder to do. And in fact, it would be impossible to do because the trees would grow by the time you finish measuring all of them. And you couldn't possibly, it would take you more people than you know what to do with to measure the diameter breast height of every single tree in the Coconino National Forest. Another example would be if you wanted to know the opinion of every Amazon shopper about how their last purchase was. You could basically do that, but it will constantly be changing because there's new people all the time that are buying from Amazon. So you can't always get a population. So what we do is we take samples. And a sample is basically a set of measurements from some individuals or objects. So it's only from a smaller collection. It looks just like the population, except instead of having the word all, we have the word some. Because you're not going to measure every single solitary object or individual. An example would be for the diameter of breast height. You could go out and measure 100 trees and their diameter of breast height, and that would be easy for you to do, and you could be able to get that information. So we could definitely have that information happen where you could do that. So that's kind of what it looks like. That's what a population sample looked like in a variable. So as an example here, what is the average income of all NAU students? So we're going to take a sample of 100 NAU students and find out their incomes. So the variable that we're measuring is the income of a person, an NAU student. We wouldn't be doing finding the average. You can't measure an average. You would have to actually measure every single NAU student and get their income. So your population is the income of all NAU students. Since you could conceivably do this, but again, the NAU students are constantly changing. Students come in and leave, graduate, and so forth. So getting all of them would be almost impossible. So we could take a sample. Plus, it would take a long time to get all 23,000 students' incomes. So instead, we could take a sample of an income of just 100 NAU students. So notice instead of saying all, we're going to take 100 instead. And in this case, we can also measure something called a parameter, because that might be what we actually want to calculate. So we want to know what is the average income. That's what we want to actually know. But so that would be our parameter that we're looking for. Parameter is a number that's calculated from the population. So let's go put that information in here. So we have a parameter, and that's a number calculated from the population. Again, since we don't always have the population, we can get a number from the sample, and we call that a statistic. So a statistic is a number calculated from the sample. All right, so going back to this example, my parameter in this case is the average income of all NAU students. So that would be my parameter. That's the number from my population that I want to find, given information about. Since I can't get all of them, so it would be very difficult to get every single solitary student's income, I could get my sample, and from my sample, I'm also going to calculate the average income. But I'm only calculating the average income of those 100 students. So that's what we call a sample statistic. So it came from our sample, and it's a statistic because it's a number calculated from the sample. Notice population, parameter both start with P, sample, statistics both start with S. So that's kind of a way to remember what it is. And one thing to note is a sample should definitely be representative of the population. So if you want to find out what is the average income of all NAU students, you would go and ask all NAU students. Your sample would be 100 students, but that wouldn't be the first 100 students you met going into the union at the school. Some of them may not have an income. Some of them may be, if you do it at a certain time of day, the people who are working are at work. And so you would only be catching students who may not work or have different types of jobs. So you want to actually get a representative sample. And we're going to talk about how we collect samples. So that's actually our next thing, is to talk about how we do that. There's some other definitions that are in the section. So I would like you to please make sure you've read the chapter so that you can catch some of those definitions. They're mostly about what kinds of variables there are and what they look like. And so make sure you've read about those, because there will be information on those. Now we're going to talk about how we do sampling. So section 1.2 talks about random sampling. And actually, it shouldn't just be random sampling, because there's other types of samples. So we're going to first talk about something called a simple random sample. And a simple random sample is that every sample of size 100 size n has the same chance of being chosen. So let's look back at that idea of the NAU students and getting 100 incomes of NAU students. That if we took a random sample, it means that any collection of 100 students' incomes would actually have the same chance of being chosen. So if I pick 100 students and ask them what their income is, those 100 students have the same chance of being selected as any other 100 students collection that I have. So that's what we call a simple random sample. It's very difficult to get a simple random sample. It's the one we like to have. It's where we want to go, but it's very difficult to get one. So there are other types of samples. Another one that actually is probably just as difficult to get and actually has a different purpose besides being easy or hard to get is called stratified sampling. And stratified sampling is where you have you're going to take your group and you're going to divide them up into what we call strata or different groups. So you're going to actually divide the population, or I should say the collection of individuals, into different groups. And we actually call these strata. And then you're going to do is you're going to take a random sample inside each of these groups, each of the strata, I should say. So where this is useful is if you have a let's say you want to know what the opinion is of NAU students about a tuition increase. Well, seniors that are about to graduate would probably have a very different opinion about it than freshmen that are just coming in. So you may want to divide your group, your every single student at NAU, into different groups of freshman, sophomore, junior, senior, and then find out what those opinions are. Another example we actually see in the news these days is where we look at the opinions of different age groups about a political concept that's happening. Another type of sample that we can have is a systematic sample. And a systematic sample is where you actually take every kth individual. So you actually pick every kth individual, where k is some number. And so you might like say every 100th person that walks by you, or every 100th bottle on the assembly line, or every 10th car on the assembly line. You would actually pick that, and K would be that 10 or 100 or whatever it is you were working with. There are two more samples I want to talk about. The next one is what is called a cluster sample. And a cluster sample is where you can divide the individuals into groups, but the groups are based on kind of more like geographic reasons or some other ways of creating these groups. And then you randomly pick which groups you're going to use, and then actually ask every individual in that group you picked. Individual in the groups. So this looks a lot like a stratified sample, except with a stratified sample, you're going to use every group. You're going to use every strata and then take random samples inside each group, each strata. Here with a cluster sample, you're randomly picking which groups and then sample every individual in the groups. So stratified uses every group and some individuals. Cluster uses some groups than every individual. And that's kind of the difference between the two. The next one that I want to kind of mention, I don't really want to mention it, but I'm going to mention it anyway, is called a convenience sample. This is one that's just easy on the most convenient for the researcher. So in other words, you go and stand on a street corner and everybody who walks by you, you ask a question. Or you measure every 10th car in the parking lot to see what kind of car it is. And you don't actually, you just walk out there and see which ones are there. That's not the best kind of sample. That's why I didn't want to mention it, because it really is not a good idea to do. But it is there in case, because some people do them, and I want you to know that they exist and they're bad samples to do. The next one that I want to mention is not actually a sample, it's a census. And that's where you collect information from every individual. And that's what a census is where you're going to collect that variable from every individual. So you're basically getting the whole population. They're not that easy to get usually, but we do actually do a census every 10 years in the United States. To figure out how many people live in the United States and live in certain areas. And so those are all there. There are other types of samples. Please read the section to learn a little bit more about them. The next thing I want to mention is there's a whole section on clinical studies and kind of what is going on with those. Please read those to give you some ideas. There's a concept in there called the placebo effect. And the placebo effect is where you give people a fake pill. So a placebo is a fake treatment. And the reason we give a fake treatment is that you want to make sure that what you're seeing isn't just because of a psychological piece that's happening, but it's about a real result. So we want to actually look at this thing called a fake treatment and look at this placebo. You can't always do a placebo though. So do be careful with some placebos that you can't actually do one. Like if you're trying to give somebody who has high blood pressure and see if a new blood pressure medication works, you can't give somebody with high blood pressure a placebo, because that would actually be dangerous to their health. You also don't give placebos in terms of animals, because as far as we know, the animal wouldn't know what the medication's for, so they wouldn't have a psychological effect of taking the medication. And a placebo is really for mostly medication, but you can use it in some other things. But you got to think about, do you want to actually create a fake treatment in every situation? So please read that section. And then the last section is also one that I'd like you to read. And this is on should you believe a statistical study? And these are kind of some guidelines to look at. So I would like you to read this section, read and see more about it. It talks about are the population goal and type of study defined? Are the sources identified? Are there any confounding variables, which are in the last section, so please read about that. Is there any bias in the study? Bias could be that somebody whose job is based off of the success of some product, then they might have a lower bias to make sure the product is successful. You can have some other kinds of bias. There's selection bias of how you select for your population and sample, and participation bias of people who refuse to be part of a study, which is always fine. People can refuse to be part of a study. We'd like to try to reduce that a little bit, but that can happen. You should also look at how you set up the survey. There's problems with wording of surveys. You want to ask the question of the results present fairly. In other words, are they presented in a way that makes sense? Are there any misleading graphs? and any final considerations that you want to think about. So that's kind of the introduction to the basics of statistics. And we'll go on to another video in a little while to talk about some other things we can do with statistics. So these are kind of the basics, and then we'll talk about graphs and numerical information later.